We are right before the RvB that's happening this Sunday. We're doing a bit of a practice session where you guys will learn how to set up a LAMP stack, and then you'll be setting up WordPress on 1, a LAMP stack, 2, Docker, and then 3, Kubernetes. The Kubernetes infrastructure has already been set up for you, but we'll go over that once we actually do the lab. So here's the agenda. We'll be going through, again, first directly on the machine itself, then through Docker containers, and finally using Kubernetes itself. So first, VM. There really isn't going to be much covered, at least on the slides today, since a lot of what you need to do this stuff is on the handbook. If you're not aware, there is a handbook / instruction guide on the Linktree, Linktree/Cal Poly Swift. I would advise you look at that since that is what you'll be doing for today's lab. So very quickly, what exactly is a LAMP stack? LAMP stack stands for Linux, Apache, MySQL, or MariaDB, and then some sort of programming language, PHP, Perl, Python. In this case, we'll be using PHP. We want to run an application on the LAMP stack. So a web application that utilizes all of these different components is WordPress. So that's why we will be setting up WordPress on a LAMP stack. As I said, there really isn't much that I need to cover on the slides itself, which is really funny because we struggled putting up the slides a little bit because my laptop kind of died, rather blue screened, but yeah. So now you'll actually be doing the first part of the lab. You'll have 20 minutes to set up a WordPress on the LAMP stack, or you'll have 20 minutes to set up a LAMP stack and set up WordPress on it. Again, here is the instruction guide on how you do it. This instruction guide should be hosted on Notion. So what it is, sorry, this instruction guide is kind of, I guess, like a Try Hack Me Room-ish. It will have instructions on what you need to complete. And if necessary, you can press the dropdown and get more detailed instructions, or you'll get detailed instructions on how to complete that step. If you haven't already, you should clone the Camino template, Spring 24 RvB practice, and you want to use the machine called Ubuntu 22.04 bare metal plus Docker. The credentials are ccdc, and that user is already sudo, so you can just sudo su if you want to get to root. And again, the guide. Yeah, sorry about pushing stuff back constantly. We'll probably cut off this section in a bit once I finish some stuff to show, I guess, a little demo, since there was some very interesting things with the Ubuntu VM. I don't know why. All right, so I think we are going to reconvene. Let's see. I believe I'm going to do a very quick demo on this real quick. I'll be using the Debian machine since there were some very interesting issues with MySQL and MariaDB on the other host. So real quick, let me share on a different computer since I'm not logged in at all on that one. Let me do that real quick. Layouts. Yeah. So I'm going to go through a very, very rapid installation of this. Real quick, let me stop displaying this. Drag this over here so other people can see what I'm doing. So real quick, I'm going to first open up a terminal session. Simple stuff. Select the user, install the required packages. PHP Apache 2, PHP MySQL, RvB, server. Yada, 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 just standard installations. If you're already done with the if you're already done with the LAMP stack installation, you can go ahead and go on to Docker. Docker should work by default with that Ubuntu machine. That's what I did test it on. I didn't test the LAMP stack on it because I thought it would work just by default, but I guess the template we have that I took from has some broken packages, I guess. I don't know why. Anyways, now we're going to go to just a convenient directory, get the WordPress. Get the WordPress files from their website. WordPress.org. I don't know why I moved it here when I really should have moved it into the var.html directory. Like that. cd into it. Untar it. Go into it. Configure MySQL real quick. We're going to create a user called WordPress. Create user WordPress. With the password of bruh, just because it's quick and easy. We're going to create a database called WordPress or WP again. We're going to grant all privileges on that database to WordPress star to that WordPress user that we just created. I have a typo. Grant all privileges to WordPress. No, on WordPress to this. We're going to flush the privileges real quick, just so that they actually apply. Oh my God. Flush privileges. And then we're going to exit. We need to restart the web server that we're hosting it on, which is Apache. Apache 2. And now if we browse to the site, I pressed the wrong button. Fantastic. I don't even know what evolution is. We go to the localhost directory. I am not used to a MacBook. Host. We'll see the default Apache stuff. But if we go to the WordPress directory, because that's where I had it set up, I forgot to modify the config file. That's why I'm in this directory. So we're going to modify the WordPress config file. They have a sample here, but you can modify it. We're going to put the information we set in the database itself. What happened to all my stuff? Okay. WordPress, WP, and the password I set on it. We're set for it. And we need to move this file to be called just WordPress-config.php. We don't need to restart it. It should automatically update and catch it if I was in the right directory. And now we can set everything up properly. Like, wow, confirm weak password, yada, 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 doesn't matter. .com, install, doesn't matter. And as you can see, we now have WordPress installed. So that was a rather rapid installation of WordPress. This unfortunately was not meant to take an hour, but that's what happens when you don't test the machines, I guess, for stuff you thought that would work. But yeah, so now let's hop back to the slideshow. Let's hop back to the slideshow. And we'll now start covering Docker. Where is this? So now we'll be covering containerization real quick. So again, a bit of a quick recap on containers. We want to run stuff in containers since containers are going to be they're going to be applications run in their own isolated environment, so they cannot easily communicate with each other. They cannot. This creates isolation. Containers create isolation between applications, which is good because if someone breaks into one of the applications on one container, they cannot easily modify stuff in a different container. They also allow you to move stuff between one machine and another very easily, since they contain everything they need to run, and they're more efficient. They're more resource efficient because you're able to put as many containers as you need, and only the amount of containers that you need for a specific application, and you're not going to have one application draining the resources of another. For isolation, you could attempt to isolate all applications. Instead of using containers, you could try to use VMs, an individual VM for each application you want to run individually. However, this isn't really resource efficient since each VM needs its own operating system, its own kernel, etc., on top of the machine it's already running on. This is much less resource efficient than containers. So a bit of basics on containerization. The Docker engine is really what allows us to run containers. It manages and allows us to build, create, and run containers, which are how we are going to isolate our applications. Next, Docker images. This is how we define what's going to be in a said container. It contains everything you need to run an application in it. It's going to contain stuff like what OS it's going to run, the files it needs to run that application, any configs, any executables or binaries, etc. And Docker images are built using a Docker file. This right here is an example of a Docker file. It's not really, or this Docker file really isn't anything I made. I just picked a random image from Google. But as we can see at the very top, this is taking, Docker images are built off of a different image. It can, the base image of this Docker container is a specific image called the node image. In this case, it's for Alpine. I'm not really going to explain the components of the Docker file since I have a better explanation inside the handbook itself. And we're a bit pressed on time right now. So yeah, explanation on how Docker files work are inside of the handbook. Next, registries and repos. Registries are a collection of container images. As you can see, this right here is a repo. I believe this is just a standard Docker Hub, or not repo, sorry. This is the standard Docker Hub registry, and it contains a bunch of different image repositories. And what image repositories are a collection of images that are all very much related. I have a better image on this slide. So this right here is the Docker Hub registry. On the bottom, we have the Python repo, and inside that repo are a bunch of different images that all relate to each other. They differ due to their tag at the very end. On that Docker pull command, you can see a colon after Python, and that is what differentiates each different image inside of a repo. That is what's called a tag. Next, volumes and bind mounts. These are both used to maintain persistence for containers. Since containers are intended to be ephemeral, once they're gone, they're not supposed to have any information. They're not supposed to persist information. The only way to maintain, or the only way to keep information from a container is to use a volume or a bind mount. The reason why you might want to do this is, say you're running a database container. You don't want that information in the database to just go away when you stop the container. And so you can either use A, a bind mount, or B, a volume. Bind mounts literally mount a file from your host onto that container, while volumes are essentially storage that are managed by the Docker engine itself. And there's probably a little bit more information that I could have added, but that information should be on the handbook. The second section of the handbook is all about Docker. And yeah, I think we should be able to do 30 minutes, but that is going to be rough for Kubernetes at the end. So yeah, we'll try 7:30. And I don't believe there will be a demo after this one, unfortunately, since I do want to make some time for you guys to have to be able to do Kubernetes. Oh yeah, just a heads up, as I think everyone's still doing some stuff with Docker. Unfortunately, I do not think we'll have time to cover Kubernetes, though there is still the guide available. There is still the guide available just in case you need it. And I would advise you to look at the guide and on your own time, work on it, since I believe it should be very helpful for the RvB. Did that not catch at all?
Budget deadline got moved. The budget deadline got extended.
Yeah, I hope I get it. Okay, yeah, it's due tonight.
Can you hear us?
I don't think it's a BRB, but. Cool. Test. Okay. Test. Test.
Yeah.
All right.
Just talk like into it.
Gotcha. You guys need it for AKSI?
No, I'm not doing
Let's see, since we don't really have, I'm gonna real quick cover some of the Kubernetes stuff, since we don't really have time anymore, especially to actually set it up ourselves. We're just gonna go over it real quick. So this is kind of an example of, can you hear me, Jacob? Des? Okay, cool. So yeah, for some reason, the Catchbox mic is not being picked up by the yeah, the Catchbox mic isn't being picked up by the computer, so we're using simultaneously the Catchbox mic for everyone in the room, and then a webcam mic. Anyways, so with Kubernetes, this is essentially the basic diagram of how it works. On the left, we have a control plane that is what actually sends instructions to all of the nodes that actually run your applications, all your containerized applications that are in pods. Here's a bunch of important terms that you need to know. Control plane is essentially the master thing that is giving all the instructions to the workers. Next, you have nodes. These are what receive instructions from that control plane, specifically from the Kube API server. There is on every node a kubelet, and that's how it actually talks with the control plane. Pods are essentially containers or collections of containers, though usually it's just going to be a single container that are running on a node. These containers are going to be your applications that you want to run on them. And to actually have a bunch of different pods available for people to use, since that's one of the features of Kubernetes, you want to be able to balance any traffic between multiple different pods. You use deployments. You use deployments to tell Kubernetes how many pods you actually want for a specific application. Next, you have replica sets, which are how Kubernetes actually maintains the amount of pods that you request. Next, you have services and ingresses. These two kind of go hand in hand. Services are how you expose ports to other Kubernetes objects. This is because you can have this is because you can have multiple different pods all running the same application. And at the end of the day, the end user shouldn't care what pod they're being sent to. They just want to be able to hit that application running on any pod. So you need a level of abstraction in order to actually access a port on any of those pods for any application you give it. To actually access it from that application from outside of your cluster, however, you need to allow an ingress. This is going to allow traffic from external to hit a service, and that service is going to redirect traffic to your application on that specified port. That right there is essentially an image of how ingresses and services work. The other stuff, config maps, secrets, persistent volumes, and that stuff isn't as important as the other stuff, but we'll still cover it really quickly. Config maps and secrets are essentially how you pass configurations into containers or into pods. One of them is for plain text stuff that you don't care about, while secrets are for more sensitive stuff like a certificate, a password, anything that is sensitive. Persistent volumes and persistent volume claims are how you're going to manage storage for containers. You can kind of think of persistent volumes as a hard drive. And a persistent volume claim is going to be something that uses up storage, or that requests to take up storage on that hard drive. Namespaces aren't too important. They're usually used to divide up resources, but you should still know that they exist, because otherwise you might be confused as to why you don't see any pods on your Kubernetes cluster. Here are some important commands that you might need to run. We're not really going to go over it since there are explanations for it, but of note, apply is to apply any configurations you've made. Git is to get any information about a specific pod or pod deployment, etc., depending on the resource you specify. Edit allows you to edit whatever resource you want directly instead of recreating it off of a YAML. And there's a bunch more that, again, you can read. This is on the link tree. So, as I stated before, deployments are how you actually scale up applications. And here's one example of a deployment using Keycloak. Here's the example, like I said, and we're going to explain different components of it. So first, we have API version and kind. This is telling Kubernetes, hey, we want to create a deployment when we apply this YAML. Next, we're calling this deployment Kubernetes and adding a label called app with the value of Keycloak. This is very important when we want to refer to this specific deployment for other things like services, mainly services. Next, this section right here, spec replicas, that is telling us, hey, we only want to make sure that there's one pod available of this specific type. If we wanted to have high availability or have multiple pods depending on traffic, sorry, let me rephrase that. Occasionally, you may want to have more than one pod just in case you're getting a lot of traffic. You can specify that you want more replicas of this one pod, and then you'll have more pods available for customers to use. And a bunch more labeling stuff. It's not too important. Here is where we're actually explaining, or here's where we're actually specifying what should be run in this container or this pod. We want to run a container called Keycloak using this specific container image from the Quay.io registry. This is the same concept as Docker images. So yeah. Next, we're telling it to start when this container or when this pod is started. And we're giving it a bunch of different environment variables needed for this container image to run. Next, on ports, we're telling it to expose port 8080. And this is needed for your service to actually hit this port. We're exposing a port on the container just like we would for a Docker container. And next and finally is the readiness probe. This isn't too important. It usually tells the container, or it tells Kubernetes that this endpoint should be used when checking whether or not the container is up and running. But it's not actually needed. I've had a lot of containers fail the readiness check, but it just works. So not too important. Next, services and ingresses, as I stated before, are how you actually route traffic into a pod running on a Kubernetes cluster. First, we'll explain services. Here is an example of service, again, for Keycloak. We're calling it a service, or we're creating a service from this YAML. Again, naming stuff. And then finally, we are targeting a port that we exposed on the pod. And we're naming this exposed port on the service HTTP. Let's see. And like I said before, as I said before, when we named the application on the deployment, we gave it a label called app Keycloak, and this is used here to find any pods running in a deployment. And if it has this specific label, app keycloak, then it will attempt to expose or attempt to attach the service to that pod. Finally, ingresses are how you're actually going to access it externally. At the top here, we have, again, we're calling it an ingress. Here, this is something we're using from a ingress load balancer called Ingress Nginx. I'm not too familiar with how it works. However, it's how traffic gets redirected between different services, I believe. Yeah, I believe I have more information on this on the actual document itself, but there's also documentation for Ingress Nginx. These are just the metadata tags required for this ingress to work. Next, here is the actual meat of this ingress. We are at the very top, we're specifying it as TLS, meaning this is going to be HTTPS. And for the rules, so how Nginx works, or at least this Ingress Nginx controller works, is it works off of your host header. So if you access this, if you were to try to access Kubernetes, a Kubernetes cluster via IP directly, and only using IPs, you'll get a 404 error. The reason for this is that Nginx is going to attempt to redirect you to a specific service depending on what you have for your host header. You can modify your host header via changing the URL or sending it as like a request in a curl request. But if you don't use that specific host specified in this ingress, then Nginx will just give you a 404. And this host that we're specifying is sso.rvb.testing. So if you don't have this in your URL, then you won't access the service. And the rest of this stuff is for this ingress to point to a service. In this case, we're pointing to that keycloak service we created above here. Port 8080, or port 8080, and path is not really important. So yeah, and with ingresses, you can actually combine a bunch of different you can have one ingress point to a bunch of different services. That way you can apply them all from one file. Here we can see we are creating an ingress that has services for both Keycloak and WordPress services. Finally, you can combine everything together in one single YAML file and apply all of that in one go via kubectl apply tac f and then the file name. This is very nice for organization, but I would keep that ingress separate since the ingress may point to a bunch of different services that all relate to a bunch of different deployments. That was really what I wanted to cover for Kubernetes. Unfortunately, we didn't really have enough time for you guys to actually mess with it, which really sucks since the best way to do this is to mess with it yourself and to follow the instructions. And especially with troubleshooting, that is something you don't really get just by reading. So while I was unfortunately unable to give you guys the time to set up services or set up pods on a Kubernetes cluster, there might be some time between today and sometime between today and sometime on Saturday. You should be able to, at least if you have the time, spin up a WordPress a WordPress pod on a Kubernetes cluster that's already provided to you. So yeah, unfortunately, this is where the meeting is going to end. If you do have any questions, please do reach out to me on Discord at HGWJ. Wow. But yeah, this is where the meeting will end.